Good afternoon. Thank you, Soren, for your kind introduction. Thank you for inviting me. I am really happy and deeply honored to be among you in this great convention to give you an insight of what this EOLAB project is. So EOLAB, maybe you heard about it. I hope so. It's this extraordinary research prototype consuming 1 liter per 100 kilometers that we enrolled, that we revealed at the Paris Motor Show in 2014. So it's an object, it's a car, but much before being a car, EOLAB is this. Impressive, isn't it? Well, this is only aimed at stunning you right from the beginning, and convincing you that EOLAB is not only a communication object, it's really an engineering project, it's a research, it's science. And this equation, as intimidating as it may seem, actually, it's telling a very simple story. It's telling a story that if you want to get a car moving, basically you need to balance these two terms. On one side, you have the driving terms, the engine. On the other one, you have the resisting terms. And this equation was true 100 years ago. It will be still true in 100 years. To get a car moving, you need to have both terms balanced. And having a deep look at the resisting terms, well, what you see is that the weight is occupying two of the terms, and that the aerodynamic resistance, the SCX or the CDA, is occupying one important term. And the bad thing about what happened in the past 30, 40 years is that these resisting terms, the weight and the aerodynamic drag, they constantly increased for two reasons. First, reasons that were imposed to us because we have to have cars with more and more equipments, ABS, tire pressure monitoring system, this kind of thing. Also, if we want to sell cars, we need to have to make them safer for crash. We need to embark very heavy depollution systems. So these are reasons that are imposed to us. It's not the only one. As you know, if we want to sell a car today, well, it needs to be very sexy, very well equipped. You need large wheels, panoramic roofs. It needs to be very silent, very roomy. And usually, this kind of equipment has a big impact on weight and aerodynamic resistance. And the result is, since we need to continue to balance this equation, well, basically, bigger resistance means bigger drive, bigger engine. Bigger engine means more CO2 in the atmosphere. And, well, in the 90s and the year 2000, there was this realization that we couldn't continue like this. Europe, the 27 countries of Europe decided to put CO2 on control. And, EOLAB is a research project aimed at giving Renault a portfolio of innovations to keep its leadership on the CO2 reduction in the coming years. So when I took the project in 2012, it's a project that lasted about two years. Well, we set ourselves 3 objectives that you will understand given the previous equation. First, we wanted to make the car much lighter. EOLAB is 4 meters long. Well, 400 kilos lighter on a car like this is as if we took 1 kilo out of 3. If EOLAB was a person, it means the person would have to lose weight from, well, let's say 20 to 30 kilos. So it's really huge. Secondly, we wanted the car to be really much more aerodynamic, 30% better in terms of CDA. All this was aimed at reaching a fuel consumption less than 2 liters per 100 kilometers, which means roughly 50 kilometers per liter of gasoline. So when I took the project, I thought is this really new? And the answer fell very quickly. The answer is absolutely not. Here you have a document that was published in 1987, so almost 30 years ago. And at that time, Renault was celebrating the world record of fuel consumption with Vesta 2. It was a small vehicle working on weight, aerodynamics, and powertrain. And it celebrated, the world record. So it's been 30 years that we know how to do such a vehicle. Therefore, when I took the project, simply setting the same objectives, proving that we could still do the same thing 30 years later would have been a lack of ambition. So what is new in EOLAB? Well, the really new thing about EOLAB is that all these innovations have to be done in such a way that they address popular cars that would be for everyone. And behind this notion, 3 additional constraints emerge, which are the true novelty of EOLAB. First, we wanted the car to remain good-looking, and it's very difficult to keep a car good-looking when you take off 30% of the aerodynamic drag. And it's very important, because if the car is not good-looking, well, it will be difficult to sell. And we are all very concerned about the planet when we watch TV. Well, we need to do something about the planet. But when you're in a vendor location and you have the choice between a good-looking car and a bad-looking car, maybe the planet is a little less important then. Okay, secondly, the performances. It's very tempting, obviously, to alter a little bit, safety, maybe roominess, maybe looks of the car, acceleration, when you take out 1 kilo of the 3. But if we do this, well, again, the car will be very difficult to sell. And a car that doesn't sell has no effect on CO2. Lastly, but maybe most importantly, cost. We don't expect our clients to be much richer by 2020 than they are today. And even if they were, probably they would not be ready to spend a bigger amount of their budget on a car. So the car has to remain at the same cost. So how do we resolve this apparently unresolvable equation? Well, first of all, you have on screen here what we decided not to do, which is the classic solution you have in the street today. You take a car, conventional, and you put an electric engine on the top of the thermal engine, a large battery, and because the car can drive part of the time electric, well, yeah, you can reach fuel efficiency without changing much. The problem is, by doing this, you have to put such a large battery that the car becomes very heavy and very expensive. All the cars available on the market today, the Golf GT, the Audi A3 e-tron, the Volt, the Chevy Volt, and so on. All of them are above 1.5 tons. None of them is below 40,000 euro, which is not the definition of a car for everyone. So instead of that, we decided to proceed in 2 steps. First, making the car lighter, and then hybridizing it, but with a very small battery because we made the car lighter in the first place. And therefore, reaching the fuel efficiency without increasing the cost of the vehicle. In other words, the cornerstone of EOLAB, the novelty, is to leverage as much as possible the virtuous circle of lightweight, which is 1, making the car a lot lighter. Because the car is really lighter, I can reduce the engine size without changing acceleration power. And because the engine is smaller, it is also cheaper. So all the money I save on the engine, I can use it to finance my lightweight and aerodynamic cocktail in the first place. So instead of putting more money in the car, the spirit is to shift money within the car from the mechanical components to the lightweight and aerodynamic technologies. So given the ambitious objectives of the project, obviously we had to address many innovations, about 100, which are represented there. We don't have time to go over all of them, obviously. I will give you a few examples, but each of them are revolving around 3 pillars, which is 1, aerodynamics, 2, lightweight, and 3, powertrain hybridization. Let's go over the first pillar, which is aerodynamics. Okay, so to explain the aerodynamic of the car, well, most of the effect was done by simply changing the global shape of the car. If we overlay the 2 cars on one another, you will notice 2 things. First, well, EOLAB is slightly lower than a conventional Clio of today, about 50 millimeters. But most of the effect is done by the sag of the roof in the rear. And this is very unexpected to me. I'm not an aerodynamic engineer, and like many people, well, I expected that if you want to get great aerodynamic, you need to do something in the front, you know, like an airplane, like a jet fighter. All the aerodynamic guys told me, no. Well, you need to do something about this. You need to reduce this surface, because this surface is where there is a parachute effect, a suction pad effect. So if you make it smaller, the car cuts through the air a lot easier. Okay, so we did that. But the problem is, if we had left the passengers in the same location, we would have had a problem with the head clearance. And we want the car to have the same performances, the same roominess as the initial car. So we had to do two things. We had to lower them in the car, about 50 millimeters, but also shift them frontwards 150 millimeters, which is a lot. And doing this, we could restore the head clearance, the knee clearance, but we caused a big housing crisis under the hood, because by lowering the passengers here, we also had to lower the hood to keep this angle constant. And therefore, there was a lot less vacancy in the engine compartment. So you see, you start with a problem in the rear, and you end up exploding your engine compartment. This is really something that you cannot see on Excel. You need to get the job done to really see this, and this is why it was so important for us to manufacture a real car. Okay, watching the story from the top, basically you get the same image. You get also this kind of inverted water drop shape, but this time we did it by the track. The track is the distance between the wheels, and in the rear, it's 100 millimeters narrower than in the front. And this enables us to make it a lot more aerodynamic, obviously without changing roominess, elbow clearance, and obviously also without changing the global dimensions of the car. It had to remain the same length as the Clio. So doing this accounts for 3/4 of the progress. And it's very interesting because doing this, we haven't spent a single dime. It's only brain juice, and brain juice is free, okay? So it's important. Obviously, we didn't do all the progress with this. On the top of that, we had to add some active technologies, active flaps, spoiler on the front, flaps in the rear. We have also an active height riding suspension. We have some active wheel caps, and also some video rear view mirrors. So let's have a look at them, at all these features through this little video clip. Aerodynamics. And as you know, as I told you, EOLAB is also about lightweighting. So let's see what we have to say on lightweight on EOLAB. And the question is, well, how do you take off 400 kilos out of a Clio? Well, I can tell you if there were 400 kilos useless on the Clio, you would know. It's a difficult thing. It's 30%. And since I didn't know how to spread it, well, basically, I asked everyone to take off 30%, which gives you pretty much this result: 130 on body in white, 160 on chassis and powertrain, and the rest on trim and equipments. Let's start with the biggest part, or macro part, which is the skeleton of the car, body in white, which today, as you know, is made of steel, which is a very performant material, easy to manufacture, easy to weld, easy to paint. But if we had pushed the steels to their limits, maybe we could have saved 15, 20%, no more. We were far from the 30% needed. So instead of that, we had to go for a multi-material approach, mixing 4 types of materials. Steels, but really advanced steels with extra high resistance, aluminum in all their forms, magnesium, and polymers. And the spirit is to put the right parts in the right location to get maximum lightweight. But obviously, keeping in mind that we cannot spend all the money on one titanium part, obviously. Because remember, the money is coming from the virtuous effects, from getting the engine slightly smaller and other mechanical components. So to do this, the choice of parts was done with maximum lightweighting in mind, but always keeping costs down, which means having a serious look at the impact in our plants. If making the body requires to change all the robots of all the plants in all the countries in the world, you can imagine that it will have a huge cost. Same for painting lines. So obviously we had to do this choice very wisely, and this is how we came up with this particular combination. Chassis also has cool features. I will give you just a few of them. For instance, this aluminum casting subframe and TV links. On the rear, this very advanced torsional beam made of a composite material beam glued to aluminum casting arms, which reaches 9 kilos only for this part. We had to go for a very advanced braking system with no master vac. This system we developed with Continental basically combines in one simple box all the functions of the brakes, actuation of course, but ABS, ESP, decoupled braking, also electric parking brake. And without master vac, remember that we didn't have much vacancy under the hood, so it was good to put everything in a very small box. The tires also we developed with Michelin. We did lots of partnerships with major automotive suppliers. Well, the tires, we developed a specific size, 145 narrow tires. It's really narrow. We hadn't seen this kind of narrowness since the 70s or 80s. And it plays a role of the aerodynamic, the weight, and the rolling resistance. And the key was how to integrate them in the car in such a way that we wouldn't see too much the narrowness and it wouldn't be read as a fragility. But with good designers, you can find aesthetic tricks to do it. Okay, regarding equipment, an example on glazing. This windshield is 3 millimeters thick compared to the 4.5 of a current Clio, so 30% lightweight. We did things on the trims, also on the seats. For instance, these 2 seats we did with Sforcia, they saved 12 kilos because they are made of a combination of magnesium and composite. Also an example of the exhaust line, we used a special technology to cut the exhaust line in 2. The exhaust line doesn't go till the end by a system of Helmholtz resonator made of plastic. So all good ideas that were put to achieve this lightweighting result. And we go to the last pillar, the last theme, which is powertrain. And EOLAB is equipped with a hybrid, plug-in hybrid powertrain. And a plug-in hybrid is basically a combination of a thermal engine, which we see here, with an electric motor. You remember this 49-degree engine tilted to be able to restore the pedestrian shock buffer. It's a small engine. The 3-cylinder engine, 1,000 cc, 75 horsepower. Typically, it's the kind of engine we would put on a Twingo. Except here, we are putting it on a car that is the size of a Clio. And it's thanks to the fact that EOLAB is a lot lighter, so you get the same acceleration in the end. And the true innovation of this plug-in hybrid powertrain is seen from the front. Well, here you can see the internal combustion engine, 3-cylinder. And here, usually you have the clutch, but in the case of the Z hybrid, basically, you have an electric machine, and there is no clutch any longer. That's why it's very light, very compact. Actually, the gearbox is this little tiny thing, and there is no clutch any longer in it. This is the result of a 3-year project that was done, that was carried inside Renault, and that led to this, to about 40 patents and a very specific hybrid powertrain that will very soon appear on Renaults in the future. And the great thing is that you can fit it exactly in the same width as a manual transmission. I'm not even talking automatic, manual transmission. Same weight, same cost, same width. So it's very well suited for little cars like this. Also, EOLAB is equipped with a power battery of 6.7 kilowatt hour, which is about 1/3 of what you would get in a Zoe. And nevertheless, EOLAB can drive up to 60 kilometers, zero emission, purely electric. It means with EOLAB, you get kind of a fully electric car, okay? Fully electric car during weekdays, and still you have the fuel autonomy of a gasoline engine during the weekends. And this is another illustration of what the virtuous effects of lightweight are. Okay, time for conclusions. And what do all these good technologies give us in the end? First, let's remember what a 4-meter-long vehicle of today called a Clio looks like. Here we used quite a good engine Clio because we used a 120 horsepower Clio. It's a kind of a GT. It's weighing today 1,200 kilos, 1.2 tons, which gives it an acceleration of 9 seconds from 0 to 100 kilometers. And this car today uses 5 liters per 100 kilometers, which is roughly, about 19 kilometers per liter. Well, before going to the final result, which, is 1 liter per 100 kilometers, let's make an intermediate step, which is, I think, at least as important as the final result. And it's this one. This intermediate step is, what if I did only the lightweight and aerodynamic progress without changing the engine technology? Well, the result is probably my car would be in the order of 3.6 liters per 100 kilometers, which is about 28 kilometers per liter. So it's almost half of the global progress made with the total content. And it's very important because this car would cost exactly the same price as a Clio of today if we could manufacture it in our plants. And this is a direct illustration of what the virtuous effects of lightweight are, because this car, instead of weighing 1.2 tons, weighs only 800 kilos. It's the weight of what we had on the Super 5 or a Renault 5, It means a car of the 80s. And the good thing about this is that you can keep the 9 seconds acceleration, but now you need only a much smaller engine. 90 horsepower is enough. So it's a direct illustration of what I was telling you about virtuous effects. Well, of course, you know that EOLAB has a plug-in hybrid powertrain. So doing so, we had to make it slightly heavier because we have to fit a 400-volt battery. And also some power electronics. But doing so, we can achieve 1 liter per 100 kilometers without changing acceleration. So this is how we could, match the objective and even exceed the objective we set ourselves with 1 liter per 100 kilometers. But this is not the most important thing. The most important is we did it in a way that would be for everyone. It means cars that people would still desire to buy, cars that have the same performance as today, and cars that globally cost the same amount of money. So all these technologies, they are valuable because they will land in real Renaults of the future in various horizons. Well, people ask me often, when do we manufacture EOLAB? The answer is EOLAB as is not scheduled to be produced, but each of its 100 innovations will land sooner or later in the cars of the future. For instance, you heard that the Espace is 250 kilos lighter than the previous generation. Well, this is thanks to one of the technologies present in EOLAB. It's hot stamping on steels that enable making thinner gauges of steel. At the other, this appears already today and will continue to appear in 2016. At the other end of the spectrum, you will find multi-material bodies with plastics and polymers, which are difficult to manufacture in our plants, but which will appear at the end of the decade, maybe slightly after. In the middle, well, lots of cool technologies will also appear. For instance, in the coming years, you should see appearing the video rear view mirrors. So, in other words, keep in mind that if these technologies are in EOLAB, it means engineering somewhere is working to keep providing you, to keep supplying you with good products, with cool products, with useful products. This is what I wanted to share with you, and thank you very much for your attention.